Welcome to Multiple Spanning Tree Protocol. Synchronization of port roles. When the device receives a proposal message on one of its ports and that port is selected as the new root port, the RSTP forces all other ports to synchronize with the new root information. The device is synchronized with superior root information received on the root port if all other ports are synchronized. An individual port on the device is synchronized if that port is in the blocking state. It is an edge port, a port configured to be at the edge of the network. If a designated port is in the forwarding state and is not configured as an edge port, it transitions to the blocking state when the RSTP forces it to synchronize with new root information. In general, when the RSTP forces a port to synchronize with root information and the port does not satisfy any of the above conditions, its port state is set to blocking. Sequence of events during rapid convergence. After ensuring that all of the ports are synchronized, the device sends an agreement message to the designated device corresponding to its root port. When the devices connected by a point-to-point link are in agreement about their port roles, the RSTP immediately transitions the port states to forwarding. Bridge Protocol Data Unit Format and Processing. The RSTP BPDU format is the same as the 802.1d BPDU format except that the protocol version is set to 2. A new 1-byte version 1 length field is set to 0, which means that no version 1 protocol information is present. Topology Change Acknowledgement, TCA. The sending device sets the proposal flag in the RSTP BPDU to propose itself as the designated device on that LAN. The port role in the proposal message is always set to the designated port. The sending device sets the agreement flag in the RSTP BPDU to accept the previous proposal. The port role in the agreement message is always set to the root port. The RSTP does not have a separate topology change notification, TCN. BPDU. It uses the topology change, TC, flag to show the topology changes. However, for interoperability with 802.1d devices, the RSTP device processes and generates TCN BPDUs. The learning and forwarding flags are set according to the state of the sending port. Processing superior BPDU information. If a port receives superior root information, lower device ID, lower path cost, and so forth, than currently stored for the port, the RSTP triggers a reconfiguration. If the port is proposed and is selected as the new root port, RSTP forces all the other ports to synchronize. If the BPDU received is an RSTP BPDU with the proposal flag set, the device sends an agreement message after all of the other ports are synchronized. If the BPDU is an 802.1d BPDU, the device does not set the proposal flag and starts the forward delay timer for the port. The new root port requires twice the forward delay time to transition to the forwarding state. If the superior information received on the port causes the port to become a backup or alternate port, RSTP sets the port to the blocking state but does not send the agreement message. The designated port continues sending BPDUs with a proposal flag set until the forward delay timer expires, at which time the port transitions to the forwarding state. Processing inferior BPDU information. If a designated port receives an inferior BPDU, such as a higher device ID or a higher path cost than currently stored for the port, with the designated port role, it immediately replies with its own information. Topology changes. This section describes the differences between the RSTP and the 802.1d in handling spanning tree topology changes. Detection. Unlike 802.1d in which any transition between the blocking and the forwarding state causes a topology change, only transitions from the blocking to the forwarding state cause a topology change with RSTP. Only an increase in connectivity is considered a topology change. State changes on an edge port do not cause a topology change. When an RSTP device detects a topology change, it deletes the learned information on all of its non-edge ports except on those from which it received the TC notification. Notification. Unlike 802.1d, which uses TCNBPDUs, the RSTP does not use them. However, for 802.1d interoperability, an RSTP device processes and generates TCNBPDUs. Acknowledgement. When an RSTP device receives a TCN message on a designated port from an 802.1d device, it replies with an 802.1d configuration BPDU with the TCA bit set. However, if the TC while timer, the same as the topology change timer in 802.1d, is active on a root port connected to an 802.1d device and a configuration BPDU with the TCA bit set is received, the TC while timer is reset. This behavior is only required to support 802.1d devices. The RSTP BPDUs never have the TCA bit set. Propagation. When an RSTP device receives a TC message from another device through a designated or root port, it propagates the change to all of its non-edge, designated ports into the root port, excluding the port on which it is received. The device starts the TC while timer for all such ports and flushes the information learned on them. Protocol migration. For backward compatibility with 802.1d devices, RSTP selectively sends 802.1d configuration BPDUs and TCN BPDUs on a per-port basis. When a port is initialized, the migrate delay timer is started, specifies the minimum time during which RSTP BPDUs are sent, and RSTP BPDUs are sent. While this timer is active, the device processes all BPDUs received on that port and ignores the protocol type. If the device receives an 802.1d BPDU after the port migration delay timer has expired, it assumes that it is connected to an 802.1d device and starts using only 802.1d BPDUs. However, if the RSTP device is using 802.1d BPDUs on a port and receives an RSTP BPDU after the timer has expired, it restarts the timer and starts using RSTP BPDUs on that port. Protocol migration process. A device running MSTP supports a built-in protocol migration mechanism that enables it to interoperate with legacy 802.1d devices. If this device receives a legacy 802.1d configuration BPDU, a BPDU with the protocol version set to 0, it sends only 802.1d BPDUs on that port. An MSTP device also can detect that a port is at the boundary of a region when it receives a legacy BPDU, an MST BPDU, version 3 associated with a different region, or an RST BPDU, version 2. Default MSTP configuration. Device priority, 32,768. Spanning tree port priority, 128. Maximum aging time, 20 seconds. Maximum hop count, 20 hops.